Sir. Good morning, dear students. In the last class, we discussed the question paper, and today we will start with some example, because I found so many of you are asking some doubts related to certain concept. So I think one, two more example needed to discuss those type of problems. Okay, so first we will discuss some example, and after that I will start with this another concept. Okay, see. So many of you are asking a question based on height attained by the center of mass. See. Height attained by center of mass. The question like this: suppose there are two balls, and those two balls have been projected. So, what is the maximum height attained by the center of mass? Let, for example, first I will show the diagram, and then okay, the question is that there are two particles or two balls, one having mass m, another is 2m. These two particles has been projected from a top of a tower of height 100 meter. So one particle projected horizontally with a speed 20 meter per second, another projected vertically with a speed of 40 meter per second. So find the maximum height attained by the center of mass from ground. So this is the question here. I would like to write two particles of mass m and 2m are projected from the top of a tower, from the top of a tower of height 100 meter, one vertically upward with a speed 40 meter per second, one particle projected vertically upward with a speed 40 meter per second, and another horizontally with a speed 20 meter per second as shown in diagram. Okay. So find the maximum height attained by center of mass from ground. One minute, just wait. So you have to find the maximum height attained by the center of mass of a system from ground. Okay, so the first idea of this, When they are asking the maximum height means upward direction, means displacement in the upward side. So upward height attained by the particles or system because of the upward velocity. So here we do not require this velocity of center of mass in the horizontal direction. We require only the velocity of center of mass in the vertical direction. So see here. So now the horizontal with a speed 20 meter per second as shown in diagram. Find the maximum height attained by center of mass of system from ground. Okay, see how to solve. First, initial. Since initially both the particle was at 100 meter from the ground, so initial height is this. Initial height I can say that is h naught. Initial height is h naught. Now here we will have two components of velocity of center of mass. One your ux, velocity of center of mass along x direction. Another velocity of center of mass along y direction. Okay. So the center of mass will go upward because of which velocity? Because of the vertical velocity. So we do not require because of the horizontal velocity it will go like this. Okay. Because of horizontal velocity it will go like this. So center of mass vertical velocity required. Initial height is this. Because of this horizontal velocity it will go here. If I am talking about the resultant velocity of center of mass means resultant of these two, it will be somewhere here like this. So trajectory of the center of mass will be like this. This is the trajectory of center of mass. In this trajectory, horizontal displacement is because of the horizontal component of velocity of center of mass, and vertically on this vertical we have to find h. So already h naught is given. As we can calculate, we will get the total height from the ground. This is the idea of the whole problem. Okay, so we require only vertical component of center of mass velocity. So u center of mass along y, same formula, m1 v1 plus m2 v2 by m1 plus m2. So this particle of mass having velocity of 40 in the upward direction, so m into 40 plus this does not have any horizontal vertical velocity, so 2m into 0 by total mass m plus 2m. So this becomes your 40 by 3. Okay, so this is your y component. Now after that you can apply. Now one more thing, acceleration of the center of mass. Okay, in which direction? Y direction. So both the particles are moving under gravity, both having the g downside. So m1 m into minus g, minus downward we are taking negative, plus 2m into minus g by m plus 2m. It will come your minus g. So acceleration of center of mass is your downward minus g. So downward is minus g and this is positive is upward. Now h, we can apply since it is constant. Acceleration is constant, we can apply the equation for constant acceleration. V square is equal to your u square plus 2as as we know. So at the highest point velocity is 0. U center of mass area 0. It is 0. Initial 40 by 3. Plus 2, a value is minus g is minus 10, s is h height, h. So h is equal to here, you can simplify 40 by 3 is 40 by 3 square by 20. So 40 by 3 into 40 by 3 by 20, 20 into 2, okay, so 80 by 9. 80 by 9 meters this. The total height from the ground. So total height from ground. Total height from ground. This is equal to h0 plus h. 100 plus 80 by 9. 980 by 9 meter. Okay? Understood? So this is the question is how to calculate the height attained by the center of mass. See, similar problem, another problem. Similar type of problem. Here okay. First, I would like to explain the question here. Here I took the two particles. Here both are projected from the same point. Here I took two particles, one on the ground, and this particle has been projected upward with a speed of 100 meters per second. Another is at a height 100 meters from the ground, and this has mass 2m. It has been dropped. It has been dropped. Now find the maximum height attained by the center of mass of system. See here. Two particles of mass m and 2m are projected as shown in diagram. Find the maximum height attained by center of mass from ground. Okay. Find the maximum height attained by the center of mass from ground. Yes. See how to solve this one. In this problem, in this case, both the particle was not at the same location. There are two different positions. Center of mass, first we have to calculate the position of center of mass. The position of center of mass, neither it will be here nor it will be here, it will be somewhere in between. Because as we know, in two particle system, center of mass position will be between the two particles. So first we will calculate the position of center of mass. Then process is same. Then the same process. We will calculate the velocity of center of mass, acceleration, and then apply this formula. See. So first we will calculate initial position of center of mass. This particle having mass m and this is your 2m. So center of mass will be on y-axis. Let this is center of mass. Y naught height. This is the origin. We will calculate the y naught. So y naught is equal to m1 y1 plus m2 y2 by m1 plus m2. m1 y1. m1 y1 means m into 0. m2 y2, 2m into height your 100. 2m into 100 by m1 plus m2, m plus 2m. This will come your 100 by 3 meter. So this y naught here 100 by 3 meter. This is the initial height. Now here we will calculate the velocity of center of mass along y direction. Then center of mass will go up, come back. So how much the UCOM along y? Same formula. m1 y1 plus m2 y2 by m1 plus m1 v1 plus m2. This has been projected with how much speed? 100 meter per second. This has been dropped. Drop means velocity of the zero initial. So m into 100, 2m plus 2m into 0 by total mass 3m. The UCOM y is equal to 100 by 3. This also meter per second. Positive indicator upward. Same thing, acceleration of center of mass. This will come here minus g. In which direction or downside? Same method. m into minus g, m into minus g, 2m into minus g, m plus 2m. Now, center of mass going up. Then it goes up to height your h. Same method, same form. V square. Final velocity is 0. U square. Initial, how much is your? 100 by 3. Minus 2a. 10 s your h. H is equal to your 100 by 3 whole square by 20. This is your 100 by 3 into 100 by 20, 5 by 3. Okay, it is your 500 by 9. So H is your 500 by 9 and initial y naught is your 100 by 3. So total height attained by center of mass. This is equal to y naught plus h, 100 by 3 plus 500 by 9, 800 by 9 meter. Got it? So 800 by 9 meter. In this manner we can solve this type of problem. So please note down this. After that session, other problem. Okay? Okay, now see some other problem. Now see, few questions are based on explosion of bomb. See, explosion of bomb or breaking of a body or breaking of a body, like these type of problems are there. Means for example, let this is the bomb and it is kept on horizontal surface, kept on surface. Now it explodes. When it explodes, then what will happen? When it explodes, different part of the bomb will go in the different direction, like this. So many particles. It means you can divide the number of particles. It may go in the different direction. So what is the most important part here? In this explosion, any external force has been applied? No. Before explosion, only two forces was there, mg and normal. And net force on the bomb was 0. Net force on the bomb was 0. It means net force on the bomb is 0. When any bomb explodes, it means there some chemical reaction happened. Those are the internal reactions inside the bomb. So no external force is acting and bomb was at rest. So as we know, according to Newton's second law, if the net force on the body is 0, so its acceleration is 0. Or it also can be defined with the first law of Newton, law of inertia. Law of inertia means if net force is 0, so body will not change its state of either motion or rest or direction. Fine. So earlier our body was at rest. Body was rest means what is rest? Velocity of center of mass was 0. If external force is 0 here, the center of mass will remain at rest. So location of the center of mass of the bomb will remain your same. So as no external force was acting, no external force was acting and it was at rest. So after explosion, location of center of mass will not change. Location of center of mass will not change. Okay. So which type of questions are there? See the question based on this. Question based on this. A bomb was kept on the ground, kept at rest on ground. It explodes into three parts of mass ratios 1:2:3. Okay. The particle of lighter mass has velocity 2I plus 3J minus 3K meter per second, and heavier mass has velocity I minus J plus 2K meter per second just after collision, just after explosion. Find the velocity of third particle just after explosion, like this. Okay, see how to solve this one. Very simple. Since it was at rest on the ground and no external force was there, external force was acting, no external force. So what will happen if a particle was at rest and external force is 0? So according to Newton's first law, it remain at rest. So what remain at rest? Its center of mass remain at rest. So velocity of center of mass will be a 0. It means m1 v1 plus m2 v2 plus m3 v3 by m1 plus m2 plus m3 must be 0. So I can say here m1 v1 plus m2 v2 plus m3 v3 equal to 0. Fine. So two velocities are given. So you have to find the third one. Their masses are in the ratio of your this. So m1 1 raised to 2 raised to 3. m1 will be your m by 6. m2 will be your 2m by 6. And m3 will be your 3m by 6. If m is the total mass, 1 by 6, 2m by 6, 3m by 6. The ratio your 1, 2 and 3. So in this lighter mass, this is the lighter mass, m1. Heavier mass, m3 is the heavier mass. So you have to find v2 in fact, v2. Now write 0 is your m1. m1 is m by 6. v1 is your lighter mass. This 2I plus 3J minus 3K plus m2 is this 2m by 6. v2 we have to find plus m3 or 3m by 6 v3 I minus j plus 2k. This is equal to 0. Now simplify. m by 6 you can take outside. 2y plus 3j minus 3k plus 2v2 m by 6 outside, so 3 times 3i minus 3j plus 6k. Simplify. 2i 3i 5i 3j minus 3j 0 minus 3k plus 6k 3k plus 2v2. v2 is equal to your minus 1 by 2 5i plus 3k. This is the v2. Okay, this is the answer. Just go with the very fundamental, basic. So as we know, if the net force is 0, the center of mass will not change its state, either rest or motion. Clear? Similarly, see another example based on this. Another suppose bomb explode means moving bomb. Another type of example. A bomb is projected with a speed 100 meters per second from ground, making an angle 37 degree with a hard rate. At the highest point of its trajectory, a bomb explodes at the highest point of its trajectory Bomb explode, better write in two parts. In two parts at the highest point of its trajectory. The ratio of two parts, the ratio of masses of two parts are are 1:3. The lighter part comes to rest just after explosion. Find the distance between the lighter and heavier part. When the distance between the find the distance between lighter and heavier part on ground when they strike the ground. When they strike to the ground. Okay. So this is the question. Now, first analysis. Here our bomb was moving, or any particle or body was moving body, and this body was moving under gravity. This body was moving under gravity. Okay, see. How to solve this one? First, analysis. Analysis is saying, okay, this is the point of projection, and here velocity has been given your 100 meter per second. So this is the trajectory of if nothing happened, if bomb does not explode, so this was the trajectory of the bomb. So trajectory of bomb is trajectory of which point? In fact, trajectory of the center of mass. Whenever we are talking about the trajectory of a particle, means trajectory of its center of mass. But, so this is moving. Why it is coming down? Because everywhere energy is acting. Gravitational force acting every time, everywhere. That's why it is coming down. But highest point, it explodes. Highest point explodes into two parts. and their masses are 1:3. In one mass your m, other will be your 3m, or one is your m by 4, another is your 3m by 4. But as I said in the last example, explosion always happens because of the internal forces. External forces is not causing the explosion. Explosion always happens because of the internal forces. So in the system, no external forces has been applied additionally. Already one force is there, mg, but additionally we have not applied any external force. So our trajectory of center of mass will not change even after explosion. First and very important point here. So our trajectory of center of mass will not change even after explosion, because in the process external force has not been either added nor it has been removed. Whatever was there, that was there before explosion as well as after explosion. First thing is this. Second thing, at the highest point, the bomb was moving in the horizontal direction. So see here, how much horizontal velocity? U cos 37. So which is your U 100? Cos 37, 4 by 5. So it will be your 18 meter per second. So this have horizontal velocity of 80 meter per second. So at the time of explosion, horizontal velocity of 80 meter per second. So in horizontal there is no forces. We can conserve momentum in a horizontal direction. So on conserving momentum at the highest point, on conserving momentum in horizontal direction, at highest point. At highest point. So initial momentum, final momentum. Initially before explosion, m into 80. After explosion, ratio of passive 1:3. So let this has been explored. One, see here it is given. The lighter part comes to rest. Lighter part have mass of m by 4. Heavier part will have mass of 3m by 4. So lighter parts come to rest. It has velocity already u10. u2 is not given. So I will find u2 from here. So m1 m by 4 into 0 plus 3m by 4 into u2. Now simplify here. u2 will come here. This is 0. mm cancel. 80 into 4. 320 by 3 meter per second. So after explosion, heavier part will go with this velocity. Lighter part come to rest. It will fall somewhere here. It will fall somewhere here, and heavier part will go somewhere here. It may strike somewhere here. We are asking this distance d. They are asking this distance. Okay? How to calculate? The time in which it has come down, in the same time it has traveled d distance. This is coming here. So first we can find out what is the highest position, height. Height h. H is equal to your highest point. As you know, u square sin square theta by 2g. U square sin square theta means vertical component, uy, u sin 37. Sin 37, 3 by 5 becomes 60. U square means 60 square by 2g. 60 into 60 by 2g or 10. 180. H is your 180. Since this particle have horizontal velocity, initial velocity of this also your 0 in the vertical direction. So H is equal to half gt square. Time we can calculate. T is equal to 2h by g root over. 2h is your 180, g your 10. How much? 6 seconds. In the 6 seconds it is coming down, means it will fall here. In the 6 seconds it will travel how much distance? D. So D is equal to your horizontal velocity of this and u2 into t. How much u2 you have calculated? 320 by 3. The time 6. This will be your 640 meter. It means distance between the lighter and heavier particle on the ground is your 640 meter when they hit the ground. Understood? Clear? Note down this. After that, see the one another example. Okay, come to the next. So these are the few problems based on your breaking of particle or body or explosion of bomb. Next is your sometime another type of questions are based on recoil speed of gun. Okay, see. Recoil speed of gun. Although these type of questions we have done, concept we have done here. See, what is mean by recoil speed? Just like some problem we have discussed, I think if you remember, if this is a one cart and a man jumps off from the cart, then cart has acquired certain velocity. So that velocity called the recoil velocity of the cart. In the similar manner, suppose a gun has been given here. This type of shape we can make for a gun, and from here bullet. bullet has been fired. When bullet has been fired, with certain speed then gun will, you will feel some exertion, or you can say you will feel some this something has been exerting something, your exerting force on you. The speed by which gun is pushing back, that speed is called your recoil speed. So the speed by which this gun is coming back is called your recoil speed. Okay. So here, when we are firing, in this case also, there was no external force was there. How the man is jumping from the cart? Man pushes cart. Man apply force on a cart in this side. Then cart apply force on a man in this side. Action reaction. So net force in the system is 0. That's why we were able to conserve momentum in horizontal direction. Similarly, here also, this is the gun and bullet. When you fire bullet, so bullet exerts some force on gun in the backward direction, and the gun exerts some force on the bullet in this direction. In fact, inside the gun some mechanism is there, some coils are there or spring is there. So when you are firing, in fact, bullet was here. When you are firing by pressing the trigger, this spring get your expanded. Earlier it was when you are loading the gun, then you are compressing the spring. In fact, when you are pressing the trigger, you are releasing the spring. When you are releasing the spring here, then your bullet will start moving like this and it comes out. In the whole process, the system is applying some force on the bullet in the forward direction, and bullet exerts some force on the gun in the backward direction. So this is the system which we are calling as a recoil speed of gun. The speed by which gun is moving back after firing the bullet is called your recoil speed. The speed by which gun pushes back after firing bullet called recoil speed. Speed of gun. Let's see one example. See one example here. A gun along with the bullet. Bullet has mass capital M. Find the recoil speed. In fact, I should write recoil. Find the recoil speed of gun after two successive fire. After two successive fire, assuming The bullet comes out with the gun with the speed u, assuming mass of bullet is small m, and bullet comes out with a speed u relative to gun. Okay, see. So how to solve? The same way. Let this is your gun. And in this gun, inside the number of bullets are there. But all together have total mass of m. All together have total mass of m. After firing, after first fire means after first fire. This gun bullet comes out with speed u. This is speed of bullet with respect to gun. It is given. Bullet comes out with speed u, and this is the speed with respect to gun. And let gun have recoil speed v1. Okay. Now in the system no external force is there. So initial momentum is equal to final momentum. Initial means before firing, just before. And just after firing. Okay, just before firing everything was calm and cool. Initial momentum 0. Just after firing, momentum of vector quantity, this we will take negative, this is positive. Momentum of your gun. From the gun, one bullet comes out. So that small m mass has come out. Total mass left over in the gun will be your m minus m. Gun is moving in this side, speed your v1. Now bullet is coming over with m. Speed of bullet with respect to ground. See, minus v1. Speed of bullet with respect to gun plus speed of gun with respect to ground. Okay. See here, minus m v1 plus m. Speed of bullet with respect to ground, with respect to gun, u. Speed of gun with respect to ground, this minus v1. Check it here. Minus mv1 plus mv1 plus mu minus mv1. This minus mv1 will cancel. The v1 is coming here, mu by m, first equation. After first collision, after first firing, the speed of the gun is this. Now second. In case of second firing, see, this is your gun. Now gun have mass your m minus m, speed your v1. This is your before firing. Before firing. After firing, mass of the gun will be your m minus 2m, because one bullet also comes out, and this is another bullet u, and let this have a speed of v. Okay. So now see how to apply. Again, conservation of momentum. Initially of this, m minus m into v1. M minus m into v1. v1 is left side, Final your gun minus m minus 2m into v2 plus mass, velocity of bullet with respect to gun. So velocity of bullet with respect to gun plus velocity of gun with respect to ground. So minus m minus 2m v2 plus m. Velocity of bullet with respect to gun, that was your u, right side, and velocity of gun with respect to ground, this is your v2 minus v2. Okay, now simplify here, substitute the value of v1 and substitute v1 minus m minus m, v1 your mu by m, and this you can simplify, minus mv2 plus 2mv2 minus mv2 minus mv2 plus mv2 plus mu. This mu you can bring to this side, or then we can solve v2 value from it. Okay, so everything is given. v2 value we have to calculate, so you can bring this term in this side, v2 m minus m, this is equal to mu this side, and bring this side here, common, so 1 plus m minus m by capital A. Now simplify, you will get the value of v2. Okay, so these are some different variety of questions. So tomorrow I will discuss the question based on center of mass frame. First I will tell you the concept, then some example based on this. Thank you. Thanks a lot.